In this short video, I'm going to demonstrate how to use software to solve linear programming problem. And so far, we learned how to draw the graph and how to find the feasible reason and how to use a corner points method. But many of you guys may be curious whether we can use any software to solve this linear programming problem. Yes, we can do. Actually, we can use the software that you are very familiar with. That's MS Excel. However, if it's the first time to use Excel, actually you need to install one add-in. Yes, that's free, but you have to additionally install the solver add-in in your current Excel software. So to do this, actually you must follow some steps. So I will not do this here because you can just do it. So how to do? Well, go to Google and search solver add-in, and it will show you MS support page, and you can click this load the solver add-in in Excel, and you guys may use either Windows or Mac. So depending on the operating system, some different instructions how to add this solver in your Excel. So I will just assume you can follow those instructions, this instruction, and I will start with my Excel where already the solver is added. Okay, so first you do this by yourself and follow my instructions here. Okay, so now let's open your Excel. After you installed your solver add-in, under data, actually you can find the solver. So for Mac version there is a solver, and the Windows version also has the same name add-in solver. You may find it. So we are going to use this solver. But before we use it, now we have to formulate the problems. Like when we manually solve it, what was the first step? We need to formulate it. So the first part is formulation, and in Excel spreadsheet, we are going to formulate it. So let me make it a little bit bigger. And I'm going to solve exactly the same problem that we have solved. That's product mix problem. 2 products and some constraints for each department. We have electronic and assembly department, and they are selling Walkman and watch TVs, and the constraints are given like available hours and week. And what we want to do, we want to maximize the profits. Okay. So here, what is the decision variables? So to set up those decision variables, let me use the first cell, A1 cell, and let me just type decision variables like this. And then we have 2 decision variables. So let's say we have 2 decision variables, X and Y. So let me just write down X and Y here. And for each X and Y as a decision maker, we are going to give some values. So let's say next column, I will type values, and let me just highlight the following 2 cells with orange color. So I did not give any values, but we may need to add some values here. For example, if you decide to produce 10 Walkman, you may have 10 here. If you decide to produce 5 watch TVs, you may have 5 here. So those values we have to decide. That's why we call this decision variables. And depending on this, you can maximize your profit. Okay, so while you are solving the problem, note that those values will change. Okay, so it's not already given, but I just add 10 and 5 as an example. What else we have? Yes, we have objective function. We are maximizing the profit. So here, let's say on D, I wanna say there is objective function. So here, let me say objective function. And the objective function is described using x and y values. In our question, we have here the information $7 for Walkman, $5 for Watch TV. So those parameters are given. So each Walkman, we can get $7. So let's call this as x and y parameters. So how can I describe this? I want to use this format. So x parameters here and y parameters on the F column. And I just use some color code here. So what would be the x parameter and what would be the y parameter? And here x parameter is given as 7, y parameter is given as 5. So parameter means for each unit how much money we can make. So if 7 and 5 is given, what would be the profit? So profit will be given next column. So let's say using G column, I want to put the information. So let's say it is a profit. And then the value of a profit would be calculated using those parameters and how many units you decide to make. So given those numbers, let's try to formulate this profit. So when you formulate it in Excel, you can use functions right here. So this cell G2 equals to, we can say that 7 multiplied by this value, x value. Currently, I just give 10. So, in this example, we can make $70 as a profit by selling X product, right? So this is the profit for X, and the plus, we multiply this Y parameter 5, and the number of units we are selling, so another 5 here. Then this formula will give you the profits. So let's see what is the current profit. But remember, note that this profit must be given as a function. The reason is, although the parameter will not change here, but those numbers will change while we are maximizing and while we are seeking for the solutions. For example, currently 55, but if you change your mind and let's say y becomes 10 instead of 5, automatically this profit will change because this is the function and this function is based on those cell values. So you can see how it's working. Okay, now we formulate the objective function, and what's left? We have some constraints. So let's try to make those constraints. Similar format I'm going to use. So we have 2 departments. So let me use these cells to describe the constraints. So how about electric and assembly department here? And I will use parameters as well. So let's say I will put x parameter and y parameters for each constraints. And then there are constraints given, kind of maximum value allowed. So I will use the term constraint. And why I put another column here? Because I want to formulate the constraint, and I will name it just as cell references. So we want to reference those cells, and I will make a formula for the constraints. If I show you one example, you may better understand what this cell reference means and what this constraints means. Okay? So let's describe these constraints. Electric department, for each unit you need to use 4 hours, and for each Y unit you need to use 3 hours. So I will just put the parameter 4 and 3 here. And then cell reference is, in this case, we wanna make a cap for this electric department's available hour 240. So constraint is given as 240. Then what would be less than this 240? That's what I name it as a cell references. So this is pretty similar to profit function. I wanna set this as a function based on those parameters. So 4 and then multiply by this unit. And this part is, let me just use parentheses to make it clear. So this part is what? The electronic department's hour allocated for X products, right? So the total hours in electronic department will be the sum of this and the Y parameter 3 multiplied by how many Y products? This cell. So B3 cell, and the sum of these two will be the total hours used in this electronic departments. Okay, so currently this is 70 hours, and this 70 hour must be less than those constraints. That's how we formulate the linear programming problems constraints. Here we can repeat similar tasks, but sometimes it would be efficient to copy and paste your formula. For example, in this case, if you just want to copy, you can just drag it, but you must be careful because in this case, assembly department, 2 hours for each X, 1 hour for each Y, and the cell reference, you cannot just copy it. If you just copy it, actually 20, if you look at this cell, this is referencing what? Parameter is okay. However, now actually you are referencing one row down, so 3, B3 and B4, because those referencing decision variables will come down by one row as well. So be careful. So if you just want to copy like this kind of cell, what you have to do is go back to this formula, and this B2, this decision variable cell, and the B3, it should not change when you copy these functions. So for this, what you have to do, you need to use $sign in front of B and the $sign in front of 2. So I guess you have learned about these notations already. So I will not give you all the details how to formulate it, but let me just use F4 functions to make to toggle this to fix the cell. So let's use F4. I just type F4, then you can see what's the change. You put $sign both in front of B and the 2. So that means when you copy this function, this cell will not change the position. So for B3 as well, so I will use $sign B and $sign 3. Okay, now we are done. And then after you do this, what you can do is you can just drag and copy. So now what you can see, this cell also referencing B2 and B3. Good? Okay, so anyway, by doing this, we can set this cell references. So you understand what this cell reference means. And for assembly department, what's the maximum hours available? 100. Okay, so that's about the formulation. So we have 2 decision variable, and these 2 decision variable will change over time. Sometimes it could be 3, it could be 5. Then depending on those number of units you are producing, your objective function profit will change. And what we want to do, we want to maximize this profit. But there are some constraints. What are the constraints? The electric department's total time used, in this case 27. Assembly department total time used, in this case 11. Each of these must be less than 240, and this time must be less than 100. Okay, so now we formulated and we now make these 2 cells can be changed. We are ready to use solver now. So go to data, and now I will open this solver. So if you open solver, there are a few parameters you have to set. First, set objective. What is objective? In our case, we want to maximize this profit. So just click it and you set this cell. So in sheet 1, G2 cell is the value that we want to maximize. So let's click one more time. So now we set up this objective. Do we maximize or minimize? Current problem is maximization. Sometimes it could be minimization as well. Later, you will solve cost minimization problem, and you can use the solver for minimization problem as well. Okay, so we are going to maximize it. By changing variable cells, that means we have decision variables. We want to change which value? We want to change these two cells, right? Currently, we just use arbitrary number 3 and 5, but it can be changed. So let's click this, and we want to choose both of them. So B2 and B3. So let's close this. So now, so far, we set objective, and we set two decision variables here. Only, one thing left is adding constraints. So we have constraints here, electronic and assembly departments. So first, let's add, and the cell reference. So here, solver is using the term cell reference. So now you understand why I name it as a cell reference. So in this case, the total time used in electronic department. So let's use this cell, and I will just click it. So I'm using this cell reference is there are different signs. In this case, less than or equal to. What's the constraints? You can just look at this. So you reference a constraint cell, and that's one constraint, electronic departments. So you can click OK, and also you can click add. If you click add, you can add additional constraints. If you click OK, you will go back and you can see whether your constraint is correct or not. Since we have one more constraint, we want to add one more. And what's the cell reference? Now, in this case, now you may better understand. So cell reference is, where is it? Here. And then it is also less than equal to, what's the constraint? The available time. So let's click and reference this cell and click one more time. So we have this constraint is ready, click OK. And also, you can explicitly add non-negative constraints, but when you use a solver, by just clicking this checkbox, you can make those variables as non-negative. In our case, this x and y cannot be less than 0. So we just click, and by default it's checked. So make those variables as non-negative. Okay, so before you run the solver, you can choose a solving method. There are 3 methods. Since we are just dealing with linear program, I recommend to use simplex LP. Actually, regardless of any use different methods, you can get the solution. But let's just use simplex LP and let's solve it. After a few minutes, it will solve and it will give you the answer 30 and 40. Exactly same answers we got using graphical method or corner point method. After you solve it, it will ask whether you want to keep this solution. And also there are 3 reports. Just for demonstrations, let me choose all 3 reports and I will click OK. If you click OK, it will give you this reports. So this is original sheet, and there are 3 reports: answer, sensitivity, and the limits reports. So sensitivity means when you change your decision variable, your profit is changing, and how sensitive is this change is, you can use this sensitivity report. And also there is a limit report. So how your margin, in your feasible reason, how this marginal limit will change your solution. But in our level, I will not look at all the details of sensitivity and the limits report. Just let's look at answer report. So if you look at just answer report, you can see objective functions profit. Original value, it was 60, but after you get the solution, you can see it's changed to 410. And then even decision variable, actually I started from 5 and 5, but after you solve it, you got 30 and 40 as an optimal solution. And then this constraint says that whether it's a binding or not. Again, I will not deal with all the details for this course, but this is also kind of useful information. But comparing your solution in your note, just let's look at this, whether you have same values for x and y, and whether you got the same profit, the objective profit you can get from the Excel server. Good. So now I think you are able to use Excel server, and you must understand this because you may need to use it for your exercise and also assignment. Okay, thank you for watching.